started. There we go. All right. So it says right here, we're going to complete a little bit more notes. We're not going to finish this section. I am perfectly fine with leaving off the last type of proof until after the exam, but I do want to go over proof by contraposition. And then after that, we'll have plenty of, well, hopefully, plenty of time to review and answer questions. I'll talk a little bit about some generic exam setup while y'all think about whether or not they're topics you want to talk about. And then we'll talk about as many topics as we can. And that'll be what it is. So, remember this is 1.5, yeah. And so last time we were going through, well, last time we actually spent a lot of time talking about, I think the warm-up and then exam, but before that, we were talking about direct proofs. So remember that was essentially just one thing follows from the next. So we have a different type of proof, and before I get into that, hopefully everyone saw my email a couple days ago on Blackboard, through Blackboard, where your homework covers more than we had covered up to this point because I was too optimistic about what we would cover last week. So the official due date has been extended to next week, the 16th. There is some that you can do, and I actually highly suggest you finish those as if it was due today, so you can at least get the practice in. But there are a couple that you can't finish, and I do list those in that email, and it's in the announcement tab on Blackboard if you want to go back and find it that way too. After today, there's probably maybe 2 or 3 of them in that section that you can even answer at this point because they're contraposition, but there are, I think, maybe just 1 or 2 that are contradiction that we won't cover until next week. But anyway, so proof by contraposition. So in 1.1, remember that the contraposition of a implication P implies Q is not Q. Why is that dragging? Oh no, I hate when it does this. Oh no. Can you not do that? Little dude. Not Q. Aha, not P. There we go. So not Q implies not P. Remember, you essentially swap it around and negate both of them. And remember also that that statement and its contrapositive are logically equivalent. So therefore, what that helps us is that if it's easier to prove the contraposition, the not Q implies not P, then we can also conclude that P implies Q must also be true. If they are logically equivalent, if the one is true, the other one has to be true. So if we can prove the contrapositive, we've also then proven the thing we initially want to prove. So sometimes it's easier to prove the contraposition than the original statement. And a lot of times what that'll look like, excuse me, is, how do I want to phrase this? It's almost like the statement you're given starts with something larger and concludes something smaller, if you will. So like this example here, prove the following, let n be an integer. If n squared is even, then n is even. Like n squared is quote unquote larger than n, not even, you know, just talking about the fact that it's a larger number. I mean, it has more substance to it, if that makes any sense. And so a lot of times if you see these statements that have like the hypothesis has a lot of substance to it, but then the conclusion doesn't, it's like it gives you this big thing that says if this thing is something, then n is something, or it just really takes just a small piece of the hypothesis, it's probably going to be easier to prove the contraposition. And sometimes they just say prove by contraposition and then you takes the guesswork out of it. So how is this going to work? So the nice thing about contraposition proofs is once you've written out the contrapositive, it essentially becomes a direct proof. So here's how this is going to happen. So first off, let me write down the contraposition. Oh no, it started again. God, that looks so gross. I don't know why it does that. Anyway, the contrapositive of this. So our initial statement is if n is even, then sorry, if n squared is even, then n is even. So we need to flip them around and negate them. So if it's not even, it's going to be odd. So our contrapositive would be if n is odd, then n squared is odd. So flip the statements, flip the hypothesis and conclusion, and negate them. Can't see the screen? Yeah. Let me reshare. There we go. It's a Teams issue. Sometimes if you come in later after I've shared it, not even technically late to class necessarily, but if I've shared it and then you come in afterwards, it is silly. Anyway, it should be there now. So that's our contrapositive. And so now essentially we just seek to prove that directly. So let me try to leave that in there. Will get me a little bit more space. So remember that proofs do often have kind of this side note thing off to the side. So let's go ahead and figure out our scratch work before we go and then write it in our fancy proof language. So if n is odd, well, what does it mean to be odd? It means we can write it as some 2k plus 1. And I don't need any subscripts this time because I only have one variable, one thing I'm considering in the proof. It's just n. I don't have any n and m or x and y or anything like that. So I just need one. So I can just name it k, regular old k. So then I want to consider what's going to happen with n squared. Well, that would be 2k plus 1 all squared, which remember is 2k plus 1 times 2k plus 1. And last week we had a little FOIL review, so if we FOIL that out, 2k times 2k will give us 4k squared. 2k times 1 will give us 2k, 1 times 2k will give us 2k, 1 times 1 is 1. Now we want this to be odd. We want to try to manipulate that to get out to an odd thing. So remember, we need a 2 times something plus 1. Well, I've got the plus 1 right here. So let me not touch that. And then can I somehow turn this into a 2 times something? Well, since all of those terms that I just underlined have a 2 in them, I can factor the 2 out. So we're going to pull a 2 out of the 4k squared plus 2k plus 2k. Well, you can combine the two 2k's together to get 4k. Actually, I'm going to do that first, just because, and let me write it out fully so hopefully people don't get confused. So then we're going to, okay, so we're going to leave plus 1 alone. It's going to stay. And then we're going to pull a 2. Now, this also happened on the quiz a little bit, so I want to talk about it. I know that they have a 4 in common. I know that. Totally see that. But the definition of even and odd is 2 times something or 2 times something plus 1. So even if you can pull out more stuff, you only want to pull out a 2. Yeah. Hopefully everyone's got that stuff in there. That's why I hadn't scrolled down yet, but here we go. Excuse me. So when you're, oh my gosh, hold on one second. Okay, so when you're trying to show that something is even or odd, you only want to pull out a 2. You don't want to pull out anything else. So that's essentially our scratch work, because now we have that n squared is equal to 2 times something plus 1, which means it's odd, which is what we wanted to prove because we're proving the contraposition. Contrapositive, I should say. Let me scroll down the tiniest bit. There we go. So now we're ready to put it together in the actual proof language. So remember, with a proof, you always start off with essentially the hypothesis. And I'm going to number these again. Again, I said this last time, usually, you know, in a normal formal proof, you're not going to number them, but we had some steps from, actually, yeah, no, it's fine. So we had some steps from the direct proof process. So if you want to refer back to that, that's what the numbers are about. But anyway, you can also just not put the numbers and be perfectly fine. So let n be an odd integer. Oh my God. Why? And then you always tell them what you want to show. So you essentially say, we want to show the conclusion. Sorry, we want to show the conclusion. Oh my gosh. So we want to show n squared is odd. This is going to drive me nuts. And now we essentially just recreate the scratch work. And again, I said this last week, but in case people have forgotten at this point.
Aaron, one question. Sorry? Is it, do we want to prove that n is odd or n is even?
So at this point in the proof, we want to show that n squared is odd because we're trying to prove the contrapositive statement. Then at the very end, we're going to say, by contrapositive, this is the same as the thing we actually wanted.
Got it. Sorry to derail.
No, you're fine. That is a very good question. So yeah, with these contrapositive proofs, we say we essentially want to prove the contrapositive. So as I said last week, you don't have to do this kind of scratch work off to the side if you kind of realize what's going to happen and you can just recreate it in the proof. But I just like to do them off to the side just in case. So essentially we just recreate all of that. So since n is odd, can I spell? N is going to be equal to some 2k plus 1 for some integer k. And remember, saying that the k is an integer is important. And then we can essentially just, again, recreate that scratch work off to this side. I might skip a little bit of the intermediate steps. Like I don't necessarily need to write out 2k plus 1 times 2k plus 1. I can jump to the FOILed form. And then I'm even going to jump an intermediate step again. And not show that I combined the 2k and 2k together. That's technically okay. Someone who's reading this should be able to know at least enough algebra to be able to follow where that came from. If you want to write out all of the steps, go right ahead. If you want to write out every single step we did off to the side, that's all perfectly fine. Now remember, the other thing is that for it to be even or odd, the thing in the parentheses, the something, has to be an integer. And so remember, we have that axiom 1 that tells us if we're just multiplying and adding integers together, we get an integer. So we do want to say that that 2k squared plus 2k is an integer. So we'll say something like by axiom 1. That's a 1, but my pen freaked out. 2k squared plus 2k is an integer. So n squared is odd. And so here's the last bit, the thing that changes with these contraposition proofs. Is there's kind of an extra last step where you say by contraposition, the actual thing we wanted to prove. So therefore, oh my goodness gracious. Therefore, by contraposition, contraposition. If n squared is even, oh my gosh, I'll try to clean it up in a second. Then, oh my gosh, n is even. Why do you do this? Silly little pen. So that's our new step with these contraposition proofs, is essentially at the very end, because technically so far what we proved isn't really what we wanted to prove. We wanted to prove if n squared is even, then n is even. But because a statement and its contraposition are logically equivalent, if we can prove the contrapositive, which we did, then we can conclude the original statement as well. Oh no, I made it worse. Okay, let me try to clean that up a little bit. Oh no, I really done did it now. Oh no, I really did. Oh no. Oh no. Crap. Oh, I found it. Sorry, I'm just, breaking my stuff. Don't mind me. Oh my gosh, go back together. Please. Questions on that while I try to make this go back to normal? Oh my goodness. And it's probably worse now. Okay, maybe at least it works. I'm gonna stop touching it now. Just make that look a little nicer. Okay, sorry about that. So, questions on that proof. We're gonna kind of take down some notes to kind of really reiterate how these proofs kind of go. Just kidding. Are we? Maybe we're not. Do I even know what my own notes say? Oh no, we don't. Okay, well then maybe I'll do something real quick then. Yeah. All right, so I thought I had a little blurb next, but I don't. So let me write down something. So a proof by contrapositive is a direct proof of the contrapositive. So the only extra step is kind of that fifth step where you essentially say, therefore, by contraposition. What you wanted to prove. So if you're asked to do a proof by contraposition, the first thing you're going to want to do is essentially state the contrapositive. And then you're going to want to prove that contrapositive just directly. So just like we were doing the other day, it's just that it almost seems weird because you're proving something that doesn't look like the thing you actually want to prove. And then at the very end, you throw in the therefore by contraposition, the actual thing you wanted to prove. Because again, since those two statements are logically equivalent, you can prove one or the other. And if you get one of them, you must have the other. So let's do one in the weird kind of fill in the blank way that your homework kind of does. I'll hold on a couple seconds in case someone's writing that down still. So maybe I'll try to leave it in there a little bit at first. So let's say we wanted to prove let n be an integer if n squared minus 6n plus 5 is even, then n is odd. So again, kind of the thing that should go off in your head is notice that the n squared minus 6n plus 5 is a lot of substance, and then you're just resulting in just regular old n. Trying to go from something with more substance to less substance is very hard to prove. So it's much easier to start with something smaller and build up to something of more substance. So going by contraposition is probably the best bet here. So if we write the contrapositive first, so we're going to flip-flop the hypothesis and the conclusion and negate them. So we would have if n is even, so not odd, then this n squared minus 6n plus 5 is not even, so odd. And so then what we're going to do is we're going to prove that. We're going to prove if n is even, then n squared minus 6n plus 5 is odd. That's what we're going to seek to actually write the proof for. So let n be a what? Well, it's going to be an even integer for this. So let n be an even integer. What do we want to show? We want to show that the n squared minus 6n plus 5 is odd. So getting into the meat and potatoes of the proof, since n is what is n? It's even. Since n is even, there exists some integer k such that what? Well, the definition of even tells us that it must be equal to some 2 times k for some integer k. And then this next bit is essentially the stuff that you would kind of do off to the side first to make sure you know what you're doing. But when there's not much space off the side, so we're just going to do it from scratch. So now we want to look at the n squared minus 6n plus 5. And what we're going to use is we're going to use this fact that we just said, well, it's equal to some 2k to replace all of those n's with 2k. So we'll have 2k squared minus 6 times 2k plus 5. If we simplify that a little bit, 2k squared will be 4k squared minus 12k plus 5. Now, we only have one next line, so I am going to branch over here a little bit to do a little bit of the intermediate steps in case you don't see it. For the actual proof, you could jump these. Of course, if you were doing this by hand, you could also write out all of these steps, but we don't necessarily need them. But what we're looking for is we're trying to make this odd. So we need to try to somehow form some 2 times something plus 1. Well, notice that 5 is odd, as we just know it to be an odd number. And that means that we can actually do this with an even number too. But the point is we could write that, instead of 5, we could write 4 plus 1. And now we have the plus 1 that we need, and we're not going to touch it anymore. So we need to see if we could pull out a 2 out of everything else, which we can, because they're all even, they're divisible by 2. Again, we could, in general, you could pull out a 4, but you don't want to when you're just focusing on proving something is even or odd because the definition only uses a 2. So we're only going to pull a 2 out of those first 3 terms, which would leave us with 2k squared minus 6k plus 2. And then the plus 1 in the back, which we don't touch. This is what they're looking for on this line here. And I just wanted to kind of show you where it came from and not just pull that out of nowhere and freak everybody out. Now, remember, the other thing about these is that you need to show that the thing inside the parentheses is an integer. But it is an integer, so we're just going to say since that 2k squared minus 6k plus 2 is an integer. Really, there should be a biaxiom 1 in here. That's bad proof language. That's actually my bad. But they at least note that it's an integer. So since that thing inside the parentheses is an integer, that means that the n squared minus 6n plus 5 is odd, because we wrote it as 2 times some integer plus 1. And then since this is a contraposition proof, therefore by contraposition, if n squared minus 6n plus 5 is even, then n is odd. Essentially go back to the thing you were initially asked to prove. Questions, concerns about that? I scrolled down just in case that weird thing on Teams is in your way. You should be able to make it go away, I think, if you like scroll over it or something. But I must have an updated version because I don't see it anymore. But anyway. Now, depending on how many other types of questions there are, we might go down a little bit. We're going to skip contradiction for now, but then there's some other extra problems at the end of this set of notes. So depending on what other questions we have, we might go and tackle those as well today. But that's what I wanted to cover. I wanted to cover contraposition proofs. So it's essentially just you state the contrapositive, you prove that sucker in a direct way, and then you just tack on an extra line at the end saying, therefore, by contraposition, what I actually wanted. So I'll leave that up for like 5 more seconds. And then I'm going to jump over to another screen real quick to write some generic stuff about the exam, just so that we are all set up for Thursday. I outlined some of it in the topics PDF that I put on Blackboard, but just in case, let me scroll down to the end, just write it all down here. So, your exam's on Thursday, of course. So here's what's going to happen. I will open it. You don't have to start it at this time, but I'm going to open at, this class starts at 11:40. It's going to pop up at 11:20. You do not have to start it early. The only reason I'm opening it slightly early is because, so we have a 75-minute class, right? Essentially what I'm going to do is I'm going to write approximately a 65-minute exam. I think I might have said this before, but just in case. So I'm going to write approximately a 65-minute exam. I have this process I do that gets me a general idea of how long it will take the quote-unquote average student. I hate saying that like that, but essentially if you're understanding a material in the way that you should be, you shouldn't take much more than 65 minutes, hopefully. Some people might finish faster, some people might take longer. That's fine. So it's 65-minute exam. It's a 75-minute class. You're going to have an 85-minute time limit. And that's why I'm opening it early, in case you have somewhere to be after this class, you have another class. So if you want, you shouldn't need that extra 10 minutes, but I also know that sometimes taking things online, the computer can be dumb and loading and blah, blah, blah. So there's those extra 10 minutes. So if you have a class directly after this or whatever, you might want to start it that 20 minutes early so that you can take the full 85 minutes if you need them. That time limit is official, so it is not like the quizzes. You will not be able to keep working after the 85 minutes. It will actually just submit itself and you'll just be done. So make sure you're keeping track of that when it's starting to get down to, you can of course hide it if you need to, but especially if you've been going for a while and you think it's starting to get to the end, you might want to pay attention for a little bit to see when that's going to be up. What else do I want to say? I haven't finished writing the exam yet, but I meant to pull this up. Based off of last semester, one second. How long was last semester's exam? It won't be the same exam, but based off of last semester's, they had also covered a lot more material. 13 questions. Some of them had multiple parts, but like the parts are things that shouldn't take a lot of time. So it's not like it, so maybe, okay, there's a lot of parts here. But so essentially, they're all kind of free response, but some of them are very quick. Like there are some questions where it's like, is this a statement? Where the answer is just yes or no. Or like, is this statement true or false? And it's just a true or false. So like some of the questions should be hopefully pretty quick. And then there are some that might take a bit more time, like translating and the proof tables and proof tables, that kind of deal. So there are usually around 13 questions, maybe around 20 to 25 parts. Again, I haven't fully finished writing it, so I can't tell you exactly how many, but that's about how it goes. I didn't do any multiple choice last year, and I think I'm gonna not do any this year either because this stuff doesn't yield itself very well to multiple choice questions. Your old quizzes. Let me triple check my. So your first official quiz. So quiz 2, you should be able to see the answers for. Quiz 3, you should be able to see the answers for. Quiz 4 might be the one that I need to fix. So Blackboard gives me terrible options for how to let you guys see your answers. Oh, actually that one too has the correct. So you should be able to see your past quiz, like the actual answers. If you go into the grade center, there should be a way to like click on the grade or something. I really wish Blackboard would like let me see what you see so I can actually figure it out. Thank you, Linda. You're able to see them all. That means I've got the right settings on because don't get me started. Anyway, so you should be able to see them if you, I think you like click on the actual number of your grade and yeah. Oh, yeah, the truth tables, looking at those answers is gonna be rough. Um, um, if you have a question on like, especially the truth table ones, shoot me an email. I can always just write it out in on a piece of paper and send it to you because yes, the way Blackboard lays out those answer keys is disgusting. Don't get me started on Blackboard. I hate it. Anyway, yeah, so that's essentially what I was about to say next. So back to generic stuff about the exam. So I will be on Teams. You don't have to be. I don't really see the point in just staring at a bunch of blank screens if you don't need to be here. Now, if you just want to come and sit in the Teams call with me and take the exam while you're in the Teams call, that's perfectly fine. I will be here. I'll be here from 11:20 to maybe give us a little bit of a extra time towards the end in case someone accidentally starts it a little late, like 1:15, something like that. I'll be in here twiddling my thumbs. So you don't have to be in the Teams call, but I will be here in case you have questions. I'll also try to monitor my email, but it'll be much easier to get into contact with me on Teams during the exam than it will. Well, again, I'll be trying to monitor my email, but I'll be monitoring Teams more closely. So that's a thing. Okay, and the last thing I kind of want to talk about is I did put this in the topics PDF of the exam review. What's okay and what's not okay for the exam. So, of course, you can use your class notes. I'm not trying to fight people on that. I know people would just use them anyway, even if I said you couldn't. So you can use your class notes. You can use what I'm going to call previously available, and I'll talk about what I mean by that in a second. That's not how you spell previously. There's an S in there somewhere. Previously available online resources. You can ask me questions, so I'm going to be super specific and say ask Erin Hannah questions. And if you need one, I don't really think we're doing much at this point in time. What am I writing? If you need one, I don't think we're really doing much that needs a calculator right now, but of course you can use one. If you don't have one, Desmos.com is pretty awesome. And it doesn't do more than I want it to do. So those are all perfectly fair game. What you can't do is you can't let someone take the exam for you because that's not bueno. You can't talk to others besides me. Can't exchange answers or talk about it or anything like that, blah, blah, blah. You can talk about it, of course, after it's closed by everyone. So, after like 2 p.m. maybe, then you can start talking about it. You can't, post online to receive answers. So, Chegg, Reddit, Stack Exchange, whatever. If you're posting that question to have someone answer it for you, I don't care if they're an internet stranger, that's not okay. None of my exam questions are on Chegg. I check beforehand. So if, magically after the exam my questions are on Chegg, someone's not going to be happy. Also, in terms of the turnaround for Chegg, most of their, quick answers are wrong, which is why it's so easy to catch when people use Chegg, because they just write wrong answers. And then it's the answer that, anyway, just don't do it. I'm not salty about it. Not at all. So that's the thing. Class notes previously. So essentially when I say previously available online resources, anything that at the start of the exam is already on the internet, you can use. So if you Google and find a very similar question, go ahead and try to use that to help you figure out how to do ours. But the actual exam questions aren't online anywhere. One other thing, when you're studying, really try to study as if this is a closed note exam. If you are going to be relying too heavily on your notes, you will run out of time. And I don't want that to happen. So try to be studying this stuff as if you wouldn't be able to use your notes, because if you have to go back to your notes at every little single question, you're not going to have enough time. If you have extra time, so if you think you should have extra time through the disabilities office, I currently don't have anyone down for this class. So if you're like, yo, I should have extra time through the disabilities office, we should get that sorted out, because I don't have anyone listed for this class. So that's the end of that. Will the counterexamples questions be findable examples like like there will actually be a counterexample? Yeah, I'll never ask you to find a counterexample and then there not be a counterexample. That would be terrible of me. So if I ask for a counterexample, there is one somewhere in life. Okay. At this point, are there any, yeah, okay. So are there any topics or questions that anyone wants to try to go over? I also mean that if I'm asking for a counterexample, you probably don't have to go that far in the integers to find one. So there might be counterexamples in the hundreds, but usually the ones I do have counterexamples, not larger than 20. The smallest one not being larger than 20. So yeah. But if there's any questions that y'all wanted to try to go over, any type of topic that's going to be on the exam, now's the time to ask. Otherwise, I'll just start pulling stuff. We might go back and do a couple more of those proofs in the notes, or we might do, so if you really want to do.
Hey, Aaron,
Sure.
It's Vince.
Hey, Vince.
Sorry. I know that someone just asked to do another proof. I was just gonna ask you, I know you mentioned it a couple times in notes past. There are a couple of those patterns that are probably going to be the things that help us solve some of these, what were they? When we have to go through and do the proofs, I guess, or we have to do the statement, show this is this, and then we use like modus tollens to, I mean, I know that sounds very broad, but what were a couple of the ones that you did? I'm looking through my notes, and I know you say like modus tollens is something that is helpful. De Morgan's is usually one of those patterns that we'll see an implication, I think is what I wrote down.
So, and we'll get to a proof in a second, but so daily. So if I'm understanding what you're saying correctly, there was one part where oh my gosh, my English is breaking. When we were doing those negation ones, where, you're taking a quantifier and then you're trying to negate it. With negation proofs, those will usually use De Morgan's, implication, and of course the universal or existential. And those are like the three main pieces. I know the one has two of them in them. The three main rules that are used in those types of proofs. When you're looking at a more generic proof, so with the modus ones, remember that these need two hypotheses. How do you spell hypotheses? Is it an E? I don't know. Anyway, hypotheses, however you spell that. So if you're going through a proof and you only start with one given, start with you will probably not use emodins. Probably not use a modus rule. Whereas if you're given two givens, you still might not use a modus. But if you have something like if you have an implication and a single, I should be careful with that term because sometimes it could be something like P and Q, so keep that in mind. I mean, a thing by itself that's part of the implication. Maybe I should say that. So if you have an implication and then you have one of the two pieces of the implication by itself, possibly with a negation, you should think modus.
Thanks. I know that's kind of like really general. I'm just trying to know which things I should on my little, I'm going to write up like, I guess, a shorter thing of notes, like my reference when I take it, and just like the things I know that I struggled with, and that would be helpful to have
yeah,
right there. Sorry.
Yeah, that's a really good idea. So I feel like those are the only tips I have. The other thing that I said a lot when we were doing these proofs is, so if I'm gonna jump away from this real quick, you are going to have this available to you. I'll probably put it into the exam like I did with the quiz, but I'll also probably have it in a separate PDF that you can click it if you have like another screen or you just want to have it off to the side or something. So you will have all these rules with you, of course. So the other thing I was really saying a lot when we were doing these proofs is the patterns thing was that, can I open this over here so I can draw on it, is to look at the patterns of what these rules are actually saying. So something like De Morgan's. Yeah, sure, De Morgan's, and let's take this one specifically. De Morgan's, you essentially distribute the negation. Not done. And switch the sign. Whereas something like, where's my implication? Where's implication? Oh my God, it's right there. Whereas something with implication, say we had the implication and we were going to the other thing, we essentially negate the hypothesis, keep conclusion, change to or. So that's the other thing I was really saying when we were doing these, is to look at the actual, like, don't get bogged down in the notation, kind of just get the idea of the pattern that rule is doing. So with those types of things, it can be better, because remember, when we're doing these proofs, it's not always P implies Q. It might be some R or not Q implies P. And if you want to use an implication on that, you have to negate the whole entire front bit and switch to an or. So it's like the pattern of the rule is also a really good thing to try to.
Yeah, thank you. And if you're going to provide this PDF, that's actually going to save some of what I was going to write out, because I was just going to make sure to write out some of these rules, have them right there. But yeah, thank you.
Yeah, so you will have this PDF. I might just put it up now, to be honest, after class, so that I don't forget, and then you can look at it. And if you want to like print it out and write stuff on it, that'll help. Then you can do that.
Yeah,
so I'll put that up after
print it out,
class.
so thank you.
Let me write that down, or else I'm gonna forget. I've been really forgetful lady. Put formula sheet up. Sticky note. All right, I'll put that up after class. So proofs. We can go to another proof. I'm gonna go back to the notes and do one of those so that we do some more of these. Also, trying to think of proofs off the top of my head is not a good idea. So we'll pop over here. Depending on whether or not someone asks another question, which please feel free to just pop a question in there now and I'll get to it when I can. Depending on if another question pops up, we might do 2 of these. Otherwise, we can just do the 1. But anyway, so proof. Wait, Daly, is this what you meant by proof, or do you want one of the ones with these? That's a question, because there's proofs and then there's proofs and then there's. What kind of proof you looking for? Are you looking for a table proof or a formal proof? Both? Okay. Let's do one of these then, and then one of the one of the table ones. With double negation, does it impact the whole thing? Let me answer that really super quick. I think what you're saying, so say you wanted to, maybe, like if you had a double negation here, if you had double negation, essentially what double negation does, no matter what is behind that double negation, it just makes the double negation go away and leaves the other thing completely alone. So double negation does absolutely nothing besides make that double negation go away. It doesn't change the other thing behind it at all. So let's do this proof and then we'll do a table one. So prove that the sum of 2 odd numbers is even. This one's just going to be a direct. So, because there's even really, well, sorry. We're going to do a direct proof here. So sum of 2 odd numbers is even. I can't even read. So the first thing we need to do is set it up. So we need to essentially set up the fact that we have 2 odd numbers. So let's just say x and y be 2 odd numbers. add numbers. I chose x and y just because I felt like it. You could use a and b, or you could just say let there be 2 odd numbers. But giving them names is going to make it a little better, because then we can say x equals 2k plus 1, and then y equals 2k sub 2 plus 1. We want to show that their sum, so x plus y, is even. So let's do our little off to the side bit over here, if we don't necessarily see what's going to happen. So if these 2 things are odd, they're going to be able to be written as some 2k plus 1, and I'm going to name it 2k sub 1 and 2k sub 2 plus 1. On an exam, if you wanted to do like 2k plus 1 and 2j plus 1, I would accept that. But I've been just doing the, I think I mentioned this last time, the subscript, because that's what your homework does, and we just need to make sure that they're not necessarily the same. So if we just look at what this sum would give us, we would have 2k sub 1 plus 1 plus 2k sub 2 plus 1. And so essentially nothing can be grouped together except those plus 1s. So we'd get 2k sub 1 plus 2k sub 2 plus 2. So we really want this to be even, so we want it to be written as 2 times something. Well, all of those terms have a 2 in it. so we can pull it out. K sub 1 plus K sub 2. And remember, when you pull a 2 out of a 2, you need a placeholder of a 1. It doesn't magically disappear. But now we've essentially set ourselves up to write the proof because we've got an even number. We've got 2 times something. So we're good to go. So essentially now we need to essentially just recreate all of that in formal proof language. So since x and y are on integers, well, actually they're not specified to be integers, but are odd, they can be written, even or odd is only in terms of integers anyway. As 2, well, sorry, x equals 2k sub 1 plus 1, and y equals 2k sub 2 plus 1. And remember, you need to specify that those k things are integers, because that's an important factor of being even or odd. So for some integers, k sub 1 and k sub 2. So that's kind of like our step 1, 2, and this is the start of step 3. And then to finish step 3, we're essentially going to recreate this work over here. We're going to start out with the sum, show that it's equal to 2k sub 1 plus 1 plus 2k sub 2 plus 1, because that's what we just said at oh my gosh, x and y are equal to. We're going to group those ones together. So 1 plus 1 is, of course, 2. So we have the plus 2, and then we can factor out the 2. So we've recreated all that work to show that we have an even number. So now we essentially just need to tell them that we have an even number. So we would say something like, therefore, x plus y is even as k sub 1 plus k sub 2. So I'm sorry, I'm taking a bit different of a format than I would do before. Usually I would call on axiom 1 first and then say, therefore, x plus y is even. But x plus y is even as that thing in the parentheses is an integer by axiom 1. So really the order that I did that doesn't really matter. So in the ones that I had done before, I usually say by axiom 1, k sub 1 plus k sub 2 plus 1 is an integer, therefore x plus y is even. It doesn't matter unless you state both eventually. So we started with 2 odd numbers. We used the definition of odd to write them as some 2k sub whatever plus 1. We want to show that they're even, so we start by adding the 2 generic things together. And we try to algebraically manipulate it into an even number, which has to be 2 times something. And so since we can rewrite that algebraically and bring it down to 2 times k sub 1 plus k sub 2 plus 1, and since by axiom 1, remember axiom 1 is just saying if you add or multiply integers together, you get integers. So since k sub 1 and k sub 2 are integers, because we specified them to be so, then adding them together and adding 1, which is an integer, results in an integer. So since we have 2 times an integer, that is the definition of even. So x plus y is even. Questions, concerns about that? Okay, I'll leave it up for a couple more seconds and then we'll go do a table one. Okay. Proofs like this, I may ask you to do from scratch. I may also give you that kind of weird setup where you just fill in the blanks. I haven't decided yet. But just know that it is possible that I will ask you to do these from scratch. Also, two more things that I just want to make sure are super clear. Well, one of them you might not have assumed, but the one thing I want to make super duper duper clear is you're supposed to take the exam at the scheduled class time. Don't assume that it's going to be open all day. It won't. So it's opening at 11:20 in case you need to take a couple minutes early so you can get to your next class. But I expect you to be taking it during the exam time, the class time. If you get here a little late and you start at 12 noon instead of 11:40, it's not going to be the end of the world. But if you try to go and get it at 11:30, 1:30 in the afternoon, it's not going to be there anymore. So, and then, oh yeah, I was like, what was the other thing? I'm gonna have a separate place for you to optionally but highly suggested upload scratch work. You know, so you can take photos, or there's this lovely thing called Microsoft Lens. It's free. And you can take a bunch of pictures and turn it into a PDF. Nudge, nudge, wink, wink. It's real great. So it's a free app, and if you can't figure it out, you can just take pictures and upload those. It's not the end of the world, but it's much easier to grade if everything's in one file. So if you can just use Microsoft Lens and put them all into one PDF, I'm gonna love you. Anyway, so especially for things like this where it might be more tedious to type it out on the computer than just write it down. You could write it down and then just upload your stuff. There will be the exam link, just like the quizzes on Blackboard. You'll open that up and there will be one like right below it that says exam 1 scratch work, and it will be optional but highly suggested to upload your scratch work there, because also the other thing, this class at this point in time isn't very like calculation heavy by any means, but if I can at least see your thinking, I can usually give a couple more partial credit points, whereas if I just have an answer and I don't know where it came from for some of these, it's like, ah. And again, in this class at this point in time, it's almost not even, doesn't matter because everything's like true, false, proof table kind of deal, so there's not a lot of work to be had, but that's a thing. So also if there's, like truth table questions on the exam and you don't feel like trying to deal with Blackboard's stupid little boxes, you can write it out on a piece of paper and send it in that way. Anyway, let's do a table one before we run out of time. Let me jump back over here. So the point of saying that I could possibly make you do those types of proofs by scratch, I will not make you do one of the table proofs by scratch. So there were ones that, like, technically, okay, let me be super clear. Proof table generic, not from scratch. It's technically a proof table setup for quantifier negation. That's from scratch. Because that one is the one that follows the very usual pattern of universal or existential negation, and then either implication or De Morgan's. So the ones where we're just trying to negate a quantifier, I can ask you to do from scratch, but something like a generic proof table, I would not ask you to do from scratch. Hopefully that difference makes sense. So what you would see in terms of a proof table that doesn't deal with quantifier negation, I'll probably set it up in 3 columns on the exam. Oh, brain. Let's do, oh boy. Oh man. 1 second. Come on. You got this, computer. I believe in you. Come on. So let's do something like, P and not R implies. Okay, hopefully I didn't write any of that incorrectly. Let me. Oh, and so we're gonna be filling out that. Yeah, okay. So I'll give you a couple more seconds to write that down. So again, on a generic thing like this, this is kind of what you would see. It would be a table and you just need to fill out the blanks that are missing. So some of them you might need to fill out the reason. Every once in a while, I might throw that you actually need to show me the statement based off of the reason that they give you. So here we're starting with two givens. We're starting with P and not R implies Q, and we're starting with not Q. So at this point for the next line, oh, sorry, I'm sorry. There should be a 1 there as well. Sorry about that. Would have been very confusing without that. So essentially we're being told that we're going to use those two givens to somehow produce not P and not R. So we go over to our rules. Can I squeeze them in here? Oh my gosh. If we go to our rules, so I need something that uses two givens. So two givens should be the tip off that it's one of the modus ones. So if we look at our modus ones, we have the implication, and note that we're resulting in the hypothesis that's negated. So which of the two moduses results in the hypothesis being negated? It's going to be modus tollens because it takes the hypothesis of the implication and results in the negation because we have the conclusion and the negation of the conclusion, which is exactly what we have here. So this would be a modus tollens rule. Let me try to. There we go. And now we're asked to use De Morgan's. We're just told that we're going to be using De Morgan's on line 3. So De Morgan's, remember, it's kind of essentially we're distributing the negation and we're switching the sign. So we're going to distribute that negation. Really, I can drop the parentheses. I don't know why I wrote the parentheses, but I'll keep them because why not? So we distribute the negation essentially. Now we do want to leave it as not. Whenever you distribute the negation, if you will, allow me to say distribute, you always want to leave the double negation. Okay, that's technically a completely different step. And then we switch the sign so that and is going to become an or. Now the next line, we're not exactly sure what step it came from, but we can probably figure it out. And so we're resulting in not P or R. So notice that that's kind of most like just the line above it, where we just no longer have that double negation. So this would be a double negation. I'm going to run out of space on line 4. Because the only thing that changed is that the double negation is essentially not there anymore. And then we're told that the next one is used from line 5. So we're going from line 5 to line 6. And we're starting with not P or R and resulting in P implies R. So if you're not sure, you would want to look over your rules and look for one that deals with both an implication and an or. The only one that deals with both an implication and an or, because you know these middle things don't count. The only thing that deals with an implication and an or is our implication. And does it follow what happened here? Well, we started with not P or R, and we are essentially taking that negation in the front and no longer having it, which is what happened here, but leaving the back piece the same. So this is exactly an implication on line 5. Questions, concerns on that? Mm-hmm. We've got a couple more minutes. Is there anything else that anyone wants to go over, or do you want me to do another one of these, or is there something else? Do you just not know what you don't know? Do a quantifier, like the negation quantifier one? I need to get on getting your homework in the grade book. I really need to do that. I'll get that up ASAP. I meant to do it over the weekend and I forgot getting your homework into the grade book. So let's do a negation of a quantifier, because that is actually kind of similar to those, but the one we just did, but we have to do them a bit more from scratch. So let's say we're starting with there exists, let's do not P of X implies Q of X or R of X. Sure. Need another parenthesis. And say we want to negate this. So this one we'll have to do from scratch. I'm going to add the reasons and steps in the same column in this one. So we always start with our given, and the given is always the negation of the thing you're asked to negate. The homework auto submits. Yeah, with the grade, yeah. And so, well, really quick, let me answer this homework question real quick. The homework auto submits on the deadline with the grade you have on the assignment currently, right? It should, yes. I did have a couple instances where one guy last semester said he did it, and he did. It's just that it didn't register it for some reason. So if the grade that I post in Blackboard, which again, I will be doing that ASAP, does not match the grade you were expecting, let me know, because sometimes for some reason it glitches and I have to like go through and manually make it accept your answer. The large majority of the time that is not a problem. But if for some reason on Blackboard you're like, yo, I got a this on the homework and it says I got a this, then let me know. Anyway, back to this. So we want to negate the thing we're asked to negate. I'm probably going to run out of space. That's something that I found on the quiz. Some of you didn't put the negation in front of the first part, and like you then did the rest of it fine. It's just that you need the negation in the front to be technically correct. Let me zoom in a little bit. There we go. So that's our given. It's always the negation of the thing you're asked to negate. So then the first thing we're going to use is we're going to use our existential negation. So it's always based off of the name of the thing is always based off of the quantifier you start with. So since we're starting with an existential, we're going to use existential negation. And I'm just going to abbreviate NEG because I'm running out of space. Existential negation, whoops, is not that. Says to bring the negation inside the quantifier and switch to the other quantifier. The other thing that happened a lot on the quiz was that people would push through the negation into an implies. You can't do that. We don't have a rule that tells us how to deal with essentially distributing a negative to an implication. So if you're starting with an implication, you have to use implication rule first. You have to switch it over to an or. So at this point, this for all x is just going to travel along with us for the rest of our gosh darn lives. So I'm going to save myself a step. And because you could technically do this in 2 steps, but some people were actually more right than I maybe, well, not more right, I was also right, but was also right on the quiz because they took the negation away instead of adding an extra negation. So with the implication rule, notice that the hypothesis essentially switches. So I could pick up another negation and write not p of x, but I can also just write regular old p of x. The only one that you really need to be careful on is De Morgan's. The De Morgan's you can't just skip. The De Morgan's always needs to write not if you already had a negation. But with the implication rule, you can kind of save yourself an extra step of doing double negation by just making it switch to the other sign, if you will. Everyone okay with that? Oh my gosh. You shouldn't be because there should be an or there. I got so bogged down in making the p of x quote unquote positive that I forgot to switch the sign. Good so far? Okay. Now that we have an or, we can quote unquote distribute that negative using De Morgan's. So again, this for all in the front is essentially just chilling. And now De Morgan's tells us that we can essentially distribute that negative and switch the sign. Oh my God. I'm an idiot. That couldn't have been an existential. That's the only thing that's going to change in this question. That had to start as a for all. This is why I don't think of things off the top of my head at the very last minute. I'm really sorry about that. The reason that that couldn't have been an existential is because I started with an implies. Remember, existential does never have an implies. Existential always matches to an and the for all always matches to an implies. Sorry about that. That was my bad. It doesn't change anything that we've done besides the name of the negation rule. We only have 1 minute left, so if you have something right after this, you might want to peace out. You can always watch the video later if you want to, but I'm going to keep finishing. I'm going to finish this out for those who are able to stay. So we used De Morgan's, and now essentially this whole front piece here is perfectly fine, and the thing we really need to deal with is this piece in the back, because we have this negation in front of this set of parentheses, and we need to distribute it through. So we actually need to use De Morgan's again. So that front bit is not going to be affected. And the back bit, De Morgan's essentially says to bring the negation inside to both terms and to switch the sign. Thanks, Linda. Now, all of the negations that are in here. First of all, none of them are double negations, so that's good. We don't need to use double negation at all. And notice that all of them are directly next to a statement. So notice that in step 4, the negation was in front of this set of parentheses that had an or inside of it, and that's what made it bad. But in our line 5, all of the negations are just in front of a statement by itself, which means that we're good to go and we're done. The other thing that makes this definitely done is that this there exists links up, links up to an and. which is what made me realize that I was wrong before. So since the there exists links up to an and, we don't have to do anything else to it. Remember, the only other thing is if you start with an existential, in a correct existential, then essentially you don't use implication at first, but you use it at the very end. So that's what I mean by those 3 rules are often used in these types of proofs. You always start with one of the negation rules, depending on which quantifier you start with. And then essentially your next step is either De Morgan's or implication. And whichever one you don't use, you will essentially have to use next. I should be careful with the word next. Maybe I should say later. So if you have to use De Morgan's first, then you'll have to use implication later. It might not be exactly right after. You might have a double negation or something to take care of first. But if you use De Morgan's first, you'll need an implication later. If you use implication first, then you'll need a De Morgan's later. In this case, we needed 2 of them. So you definitely need an implication and a De Morgan's in each one of these. It just kind of depends on where. Questions, concerns on that? And again, I'm really sorry about that quantifier thing. That was my bad. I shouldn't think of questions off the top of my head. Okay. If anyone's got another quick question, I can probably go through one more. But I do have a meeting coming up in a couple of minutes. So otherwise, also feel free to just leave. And I'll see y'all. Well, I might not see y'all, but you have your exam on Thursday. Study well. May the odds be ever in your favor.
Hi, this is Linda. How are you?
Linda. Good, how are you?
Good. I'm looking at the homework. I'm just having a difficulty trying to figure out how to do a subscript in the homework.
Yeah, so let me make sure. Let me try to get in here super quick. I think you'll just do an underscore. But let me try to verify that.
I was looking at question 2, which is, 2K_1, but I don't know how to do the underscore.
Okay, let me. Student view.
So it just be, yep, at work.
It's just an underscore?
The shift underscore.
Yeah, the little shift negative score, negative sign to get the underscore thing. Yeah.
Thank you.
No problem.
You should be also able to edit the formula when it gives you that little prompt aside. It's the second one. I believe it's function, and it has like the boxes, one's up and then one's down, and you just modify from there.
I tried that. I found that function, a sub and a superscript, but it didn't take it. It didn't like it.
Oh.
It literally told me, you cannot be understood. You cannot be graded. Here's more information, but it didn't tell me how to do a subscript.
Oh, no.
So, thank you.
Oof. Big oof.
Okay,
I was like, oh my.
For some reason, so the function thing did work for me, but yeah, also the shift, negative sign to get the underscore also should work. So it just might not like you, Linda.
I have that issue sometimes. Thank you.
You're welcome.
Have a good one.
You too.